audiences, would you, I think if we move the microphone to the center aisle, and again, I'll ask the speakers to give us their names.
Jim Leary, Purdue University. Neil, I found your talk just tremendously exciting, and I wanted to just make one comment first on the significance of it, because we've seen in this conference the use of like 7 amino acid peptide sequences for binding, and that looks like a pretty good approach, except what we don't tell you is you have to get very lucky with that 7 amino acid sequence, because at that level, and these small peptides can recognize literally thousands of different shapes within one cell, where those shapes are, every receptor may have 10 or 20 or 50 different shape regions that peptides can recognize. And so when you get very specific with a monoclonal antibody or a peptide, which is usually one thing, we recognize only one epitope, which may have nothing to do with the molecule. So for other people to appreciate this, the idea of bridging these together and putting, let's say, 2, 3, 4 peptides together to make a shape recognition, which is much, much better, that's a revolutionary concept, and I really commend you. That's tremendous. I mean, I'm very excited by that. Where do I sign up?
Thanks. Actually, I was very interested in your talk, and you and I should probably chat sometime about some things we might be able to do together in that regard.
I was going to make one comment on that. What I was showing with flow cytometry, because we thought about array systems, and you can make arrays of maybe 1 million or so. And if you think about the flow cytometric approach, actually, that I outlined yesterday but didn't have a chance to talk about, every one of those little beads effectively is an array element in one of your arrays, except that we can run 100,000 per second. Mm-hmm. So we can analyze literally billions of them and grab them out.
That did not go unnoticed by me.
Yeah. so I would definitely want to talk with you some more, but I wanted other people to appreciate the tremendous significance of what you've just done.
Was the significance of what you said, that having this double identification?
The ability to recognize complex shapes that you cannot recognize with a single peptide, and which get confused, so that you get false positive staining of those shapes throughout a cell. That's why when you look up antibodies, you'll see a lot of those ones are made for Western blots for proteins. It's because you're spreading all the proteins out, and you say, oh, well, that one that's stained there is the wrong protein, so I'll ignore it. That one's wrong, and I'll ignore it. And then they have this little note saying flow cytometry certified. What that means is that it doesn't go stain hundreds or thousands of other molecules within the same cell. Mm-hmm. So, and those are very rare and much more expensive. So if you've got a heck of a market if you can make these.
Please tell us your name.
Hi, I'm Tad Hogue from HP. I have an engineering question, follow up on the spirocytes. So as you were describing them, as you back off from the, say, 1,000 atmosphere criterion to 70, are there similar other things that you can back off on, say, in terms of the pump efficiency or the logic that you needed that would still give something reasonable, but also easier to do?
Well, the logic is quite simple. That's what I tried to point out, is that the logic is, it doesn't even need a CPU. It's just a finite state machine. It only has really two real states. Well, 4. As far as the pumps are concerned, I was not able to do an analysis on that. The technology at this point is just not there where we can build pumps that small. I mean, the MEMS region is all we can get to. And with the molecular actuators, we haven't been able to build standardized things that you can just connect into a system. So I'd say another few years before we get there. But that's a good question.
Your name and location.
Rutledge Ellis Menke, MIT, and Hong Kong U. Are you, this is for Neil, are you able to look at emerging infection or emerging antibodies that may arise from strain variation in a non-specific area that you could then build back in later?
So is the question, let me see if I understand that. Is the question, are we able, are we able to, with these kinds of methods, find something that we don't know already that it
Exactly.
exists?
Right.
Okay, so this is an interesting question. And this comes back to essentially, can you create something like an immune system outside of the body that is able to recognize something that it doesn't know ahead of time that you're going to have? One of the things that we're doing with these chemical arrays is simply looking at blood. This is the immunosignaturing aspect of this. Simply looking at blood before and after before or after, for example, you're infected with a pathogen, or you're vaccinated for the flu, or whatever is the case. And very interestingly, you can see very rapidly a response in the immune system as a signature on an array of, let's say, 10,000 peptides. Okay, so this is just your immune system binding to 10,000 peptides. So you can see, in fact, these kinds of things, and they are above background, presumably because the response is above the general background of the immune system. So that is an area that we're looking at in some detail.
Okay, and this is for Beverly. You made a comment very passing at the end about male versus female, and as you probably are well aware of, female rats in estrus don't have the same amount of damage if you do spinal cord injury, and there's been some interesting work in Georgia.
Depends on age.
Depends on age. But there's also been some very nice work in Georgia that has shown that women in estrus, if they have a traumatic injury, have much less damage. Do you think, or have you seen any evidence where you have an interaction with either the estrogen receptor, estrogen precursor, or any of the hormones?
That's a very good question that we're actually going to move to the rat to take that up, because you have to keep in mind that the fruit fly data is from a fruit fly, right. And although they're great subjects to study aging in, they still are fruit flies, and there's kind of a dichotomy in Drosophila science that says the females may be under more oxidative stress. They do have hormones that, as I see them, are the equivalent of estrogen. So what we've decided to do is move up to that, address that in a mammalian model. We don't really see the same differences between males and females at the mammalian level, but the jury's still out on that.
Interesting.
It's a dose thing, though, so it's nothing insurmountable.
Yeah, it's Qian Wang from University of South Carolina. The first question to James. Really enjoy your talk. So for the second part of the talk, talk about the cantilever. You study how the signal can induce the cell response. Have you done anything about the further modification of the surface of the cantilever?
I didn't catch that last part.
The cantilever, have you done anything further modify the cantilever surface to give some kind of nanoscale feature to see how the further fine feature can modify?
We have actually patterned the cantilever surfaces to control the size of the myotubes, because we're trying to get to the point where you can get fast twitch, slow twitch types of myotubes. And so, yes, we have started to do that. If you're asking whether or not we could do topography changes or something else, I assume we could. We haven't tried that yet, though.
Oh, that's what I'm getting to. So can you do anything about the topography to see how the topography on the cantilever can further induce on the change?
We could. Since we're using fabrication techniques for this, we could.
Okay, thanks. Another question is for Neil. So I think one of the power for the method you are using is potentially you can use the non-natural amino acid instead of normal amino acid as the building blocks. So you potentially can have more building blocks, like even you can induce the boronic acid or whatever into your system. So are you doing something like that?
Yeah. That's absolutely right. There's no reason to stick with normal amino acids. We have been doing mostly normal amino acids during the development phase simply because they're cheap, easy to come up with the right derivatives, et cetera, blocking groups on them and all that kind of thing. But we are now in the process of developing starting sets of peptides for this work that are based on non-natural amino acids as well.
Yeah.
So.
I have a following question. There one detail. When you try to optimize your final sequence, you use the mRNA and use the genetic method to optimize it. Is it right?
Well, that was what we did to show that you could do that. Just to show that the mutagenesis would in fact give the improvement that we want.
Mm-hmm.
What we're trying to do is to use entirely chemical synthesis methods and make relatively large arrays. We won't hit mRNA array type sizes, but relatively large arrays and explore that space using high throughput synthesis.
Gotcha.
Perhaps you could carry the conversation on at the break. I just, anybody else? A couple of points just to ask about. There are inherent problems with pre-symptomatic disease surges in the sense that that's not exactly prevention, it's disease detection, and which implies some procedure. Now, for many of these disease detections, not disease detections, but something that may precede disease, the procedure of finding these things and subsequent diagnosis and maybe surgery or other treatment is often more of a burden to the patient and to society than not finding it. Having said that, most of us are involved in exactly that process in about half a dozen ways, but it does carry hazards with it.
Yeah, you're absolutely right. It was very interesting. We have a group called the Center for, or the Consortium for Science, Policy, and Outcomes at ASU, and they're very interested in what are the effects of new technologies and what policies should come out of new technologies. So they held a workshop on this technology. Let's just say you had this box, right. Okay? What would happen? And they brought people in from the insurance industry. They brought people in from politics. They brought people in from doctors and hospitals. And they said, what would happen now? And there was an amazing a plethora of different views about whether or not this would actually be helpful. And as you can imagine, the insurance industry was rather distressed about exactly how they would even implement it. Who would pay for it? Exactly. Who would have the information? Where would the information go? How would it be correlated with disease state? On and on and on. And so it's a hugely more complicated problem than just the science.
Well, yeah, I think one can say that for some of these searches, it's clearly disadvantageous. The other thing, if I understand correctly, you use transferrin as that system you were talking about?
One of the proteins we've used is as a just a test case is transferrin. The other one is AKT1.
As I'm sure you know, that's a polymorphic protein,
right?
And can you detect the polymorphic differences with that?
Unfortunately, yes, because it turns out when you buy transferrin, sometimes you get one polymorphism and sometimes you get another, and we found out the hard way that those preparations aren't always the same, and so in fact the peptides that we select sometimes bind to one preparation and not another.
Are they pooled preparations that you use?
What we originally bought was stuff that you get from Aldridge or from one of the other.
That's pooled, I believe.
Those are pooled.
Bad news.
Right. Yeah. You got it. What we then had to do was take those things and purify specific polymorphisms.
By the way, if you're looking for exotic amino acids, there are some that are found in space that you don't find on Earth. Now, it'd be interesting to search for those.
Okay, I bet they're expensive.
Yeah. You can synthesize.
Yeah.
Well, thank you very much. Now, we're all for our break. Can I get an advice on when, not for lunch, but when we should come back?